All right, this video is a precursor to the last one. This is still linear modeling, but this is a little harder. So just a quick refresher. Remember, y equals mx plus b is what we need. This is our slope, which means rate. And we have some key words that mean each, every, and per. Okay, those all mean the same thing. And this one we said was our y-intercept, but it actually, what we care about is our starting cost or starting amount, and then the initial cost. Okay, so that's a quick refresher. Now, what we're going to need in this video is one other formula, and it's the slope formula. So the slope formula, remember, it's rise over run, but that's what slope actually means. But remember, we have a formula. It's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We'll have that formula, and we'll get to why we need it and each problem that we'll need it on. So you can have that down. We're going to come back to it. So here we go. On this particular problem, it says, working as an insurance salesman, Sean earns a base salary and a commission on each new policy. As a result, Sean's weekly income, I, depends on the number of new policies, N, he sells during the week. Last week, he sold 3 new policies and earned $760 for the week. The week before, he sold 5 new policies and earned $920. So that's a lot of stuff there, okay? If you're looking at this, what we do not have is we do not have explicitly the slope, and we don't explicitly have the initial cost or initial value. We have to find them out. And the reason we have to find them is because it looks as though I have an ordered pair with 3 and 760, and it looks as though I have another ordered pair with 5 and 920. What we need to do is to make sure we list those correctly in an ordered pair, and then we need to find slope through them. And then again, going and finding everything else. So what do we need? Well, remember our equation is y equals mx plus b. I do not have the m yet, and I definitely don't have the b if I don't have the m. So what do I have to do? Well, it tells me right in part A that income I as a function of the number of new policies n. So that tells me that I is actually my y value and my n is my x value. Okay? So in the now problem with the numerical values, what is n and what is I? Well, n is 3 and I is 760 for that value. For the next value, it's 5, 920. So now I have 2 ordered pairs with those numbers filled into x and y values. And what I need to do is I need to find the slope between them, because I need to find what the rate of increase is. Okay? So I'm using that slope formula from the last slide. Remember, it was y2 minus y1 over x sub 2 minus x sub 1. And I'm just going to plug in the numbers y's and x's. So 920 minus 760 over 5 minus 3. 920 minus 760 is 160 over 2, which is 80. That's my slope. So now we have slope. But again, I don't have my b value. But I do have a value for n, and I do have a value for I. So what I need to do now is I am going to substitute in one of these values into my I and n. I'm going to use this one here because it's smaller. So I is 760 equals 80 times n, which is 3, plus b. And again, I'm going to solve. This is an equation. So I get 240 plus b, and 760 still there. Remember, I have to subtract. So now when I get B, B is equal to 520. Okay? So now using my slope, 80, and using my B, 520, I can write my equation as I equals 80n plus 520. And that is the equation that I'm going to use for parts B, C, and D. Part B, how much money would Sean make if he sold 9 policies in 1 week? So the income he makes for the week is equal to $80 times the amount of policies he sells plus the 520. So this is 720 plus 520, so that equals $1,240. So the income after a week, if he sold 9 policies, would be $1,240. And remember, I need units on my answer. Dollars goes before the number, not afterwards. Part C, what is the slope? So according to your original equation in part A, the slope is 80. Second part of that, what does the slope in this equation represent? It's how much money he makes per policy. So this is the amount of money he makes per policy, and then what does he do? He has to sell it, right? So per policy sold. So the amount of money he makes per policy sold. There's many different ways you can write that, okay? Just that one there, amount of money he makes per policy sold, is not necessarily the only answer that is acceptable, okay? Case by case basis. So depending upon what you write, if it makes sense to the problem, then it will be marked correctly also. What is the y-intercept? The y-intercept is 520. Okay, and what does that represent? Well, guess what? That represents how much money he makes without selling a policy. That's the initial amount per week. So he can come in on a Monday morning, he can sit at his desk for 40 hours that week, and he'll bring home $520. Is that good? Well, I mean, that's up to you, to each their own. You might say, well, I don't have to work and I can make $520. Well, that's pretty nice, but guess what? His boss probably won't like it, so he probably won't last very long. But for the couple of weeks that he doesn't do it, then he makes $520. So what's the y-intercept represent? So amount of money without selling a policy. There you go. Amount of money without selling a policy. This is the hardest part of linear modeling. All right, and please make sure, again, you're taking notes through these videos. You are checking your work and stopping and pausing and going through and trying to figure the problem out before it's actually done. If you're kind of understanding what's happening, all right, you have to kind of just bear along, go along, and work on these problems and watch these videos. All right, on to the next one.